Now in this video, we're going to see how to actually balance chemical equations. Now when we are balancing chemical equations, the arrow is going to help us a lot. Whatever is found on the left side of the arrow is called the left-hand side, and whatever is found on the right of the arrow is called the right-hand side. Our aim in balancing equation is to make all the number of atoms on the left-hand side be equal to the number of atoms of that same element on the right-hand side. For example, here it would mean that the number of H on the left-hand side should be equal to the number of H on the right-hand side, and the number of O atoms on the left-hand side should be equal to the number of O atoms on the right hand side. So this is what we do during balancing of an equation. So what we will do, we will count the atoms. So here there is 2H, here there is 2O, here in that molecule, here there is 2H, and if you see here, there is just one oxygen atom. So now let's see, 2H and 2H, so this is good. So this part is already balanced. But here there is 2 oxygen and here there is only 1 oxygen, which means that this number needs to be changed. And how can we change that to 2 oxygen? Remember, when we put a number in front, we multiply. So if we want to change the number of oxygen, what we will do is that we will multiply a number in front. So what will multiply by 1 to give me 2? So I need to multiply this by 2. So I put a 2 in front. But when I put a 2 in front, it means that I will be changing the number of hydrogen too. So when I put a number in front, usually what I will do is that I will erase everything and count again. So right inside, I change the number of particles, so I will count again. So 2 times 2 gives me 4 hydrogen now, and 2 times 1 gives me 2 oxygen now. So I have a new number of hydrogen and oxygen. Let me see on the left-hand side. So now the number of oxygen is balanced, but the number of hydrogen is not. So what I will need to do, I will need to make this become 4. How do I multiply 2 to make it become 4? So I'll need to multiply by 2. So I will need to put a 2 in front of the hydrogen, like that. And because I've changed this, I'm going to erase and count again. So 2 times 2, 4 hydrogen and oxygen, there is still 2 oxygen. So now when I check my whole equation, I see that on the left hand side, 4 hydrogen, balanced, 2 oxygen, balanced. So this equation, this is the answer for my balanced chemical equation. So this shows that the mass has been conserved in that reaction. So this is the answer. This is the workings of the answer. You're not really marked for this. You will be marked only for the answer here. Now, initially, you might need to write these down, but as you go along, you will be able to do this mentally. So there will be no need for you to write it down. But for the initial few 10 to 15 first equations that you are balancing, make sure that you write them down for you to see, understand actually the process that is happening. Let's see another equation. So again, I'm going to use the arrow as the guiding for the side. So this is the left hand side and this is the right hand side. So let's count. 2 nitrogen, 2 hydrogen, this is ammonia, 1 nitrogen and 3 hydrogen. So I have counted. Now I will need to start balancing. Now you may start with any atom. You might start with the hydrogen or you might start with the nitrogen. I'll start with the nitrogen and then we'll see how it happens when we start with the hydrogen. So there is 2 nitrogen and 1 nitrogen here. So I will need to multiply here by 2. So let me multiply this by 2 here. Now remember, because these are together, I cannot put a 2 in the middle. I can only put a 2 in front of the molecule. So my 2 will go here, and because I'm putting 2 in the front means that this 2 will multiply with both the nitrogen and the hydrogen. So let's count again now. Because I've put a 2 in front, I will need to count all the atoms again. So now there is 2 nitrogen and 2 times 3, there was 6 hydrogen. So nitrogen and nitrogen is balanced, but hydrogen is not. So I will do a third step now. So for me to make the 2 become 6, I will need to multiply by 3. So here is my hydrogen. I will multiply it by 3 over here. So now 3 times 2 makes 6. Let me count again. So I still have my 2 nitrogen here because nitrogen has nothing in front, and these are separate molecules. You see there is a plus in between, so they are separate molecules. So now 3 times 2 gives me 6 hydrogen, and if I look on the left hand side and the right hand side, so 2 nitrogen balance, 6 hydrogen balance. So I have a balanced chemical equation, and this is my answer. And these are my workings. Let's see another one. Let's see how we would balance the equation if we now start with counting hydrogen. So again, so there is 2 nitrogen, hydrogen there is 2, and here there is 1 nitrogen, and there is 3 hydrogen. So let's see if we start balancing the hydrogen. So here there is 3 and here there is 2. Actually, I started with nitrogen because it's easier. But if you start with hydrogen, 2 and 3, the number that these 2 can easily turn into when you multiply is 6. So 2 and 3, the common factor of these 2 would be 6. So then I will turn the 2 into a 6 and I will turn the 3 into a 6. So how do I do that? So I'll times 3 here. So hydrogen times 3. And here I'll times 2. Like that. So because I've changed the atoms on both sides, I've changed the numbers of both sides, I'm going to count again. So 2 nitrogen, 3 times 2, 6 hydrogen, 2 times 1, 2 nitrogen, and 2 times 3, 6 hydrogen. So as you can see, in one step you balance the equation. So it gives the same answer, but where you start, like, doesn't really matter. You will still get the same answer. You choose which is the easiest for you. Let's see the next example now. So let's count. So iron. Now you see here, iron is just Fe. It's not Fe2 because iron does not exist as molecules of iron. It just exists as atoms of iron. So this is why it's not Fe2. Fe2 actually does not exist. So let's see. So here we have one Fe. So please don't change any number at the bottom, right? So if it's not there, it means it exists as atoms. So Fe, oxygen, there is 2 of it, so 2O. And here there is 2Fe, and here there is 3O. So again, you can start by doing by counting the Fe, by balancing the Fe first, or you can balance the oxygen. So here 2 and 3 would turn into 6. So here you will multiply by 3, here you will multiply by 2. So let's do the Fe. For us is going to be easier. So 2Fe, so I'm going to multiply here by 2. So here I need to multiply the Fe on the left hand side by 2. And I count again, so there is 2Fe now, 2 oxygen. Here I still have the 2Fe and the 3 oxygen. So now I will try to balance the oxygen now. So there is 3 oxygen and 2 oxygen. So what I will do, I will multiply this by 2 and I will multiply this by 3 so that they turn into 6. So let's see. So I'll put a 2 here and I will put a 3 here. And because I've changed the numbers, I will count everything again. So here I still have 2Fe. Here 3 times 2, 6 oxygen. Here 2 times 2, 4Fe. And here 3 times 2, 6 oxygen. So oxygen is balanced, but the Fe is not. So what I will do, I will multiply this actually by 2. So 2 times 2 actually gives me 4. So there should be 4Fe. So means that I wrongly balanced at the beginning. So I will change this and I will put a 4 now. So 4Fe. So you see that balancing equation is not a one-step process, and you can have many trial and error until you get the correct equation. So I've changed the number, so I will count again, and because I changed only on the left hand side, I will count again only on the left hand side. So 4Fe, 3 times 2, 6 oxygen. So you see Fe and F is balanced, oxygen and oxygen is balanced. So here I have my balanced chemical equation. Now you will try to balance all the chemical equations in the worksheets given and submit your answers for correction. Thank you and bye-bye.